Now let's examine the LVM GUI, a means of managing your LVM hierarchy with a graphical user interface. So let's label this as an additional task, LVM GUI. And it is enabled via the system-config-LVM utility, which needs to be installed, which was not installed by default on our server, so we installed it using yum, and it is now available. So what we need to do is create a session on the remote system that allows the X session to be exported to our local system. So let's drop the current session. The way we enable this via SSH is as follows. SSH with uppercase X to send the X11 session back to our local system, meaning for any GUI call on the remote system, the graphics will be drawn locally, and will connect as root to its IP address. This should kick the X session back. So redirects x.org session back to local GUI for utilities like system config GUI and otherwise. So let's launch this session. An alternate means of launching system config LVM, of course, would be simply to obtain a GUI on the remote system. And now this should have set up our environment. So let's do a system config LVM. Which of it tells us it's in user sbin. It may not be installed by default on your system, so just either use yum or RPM to do so. Now this brings the GUI back up on our local system. It will scan for LVM related assets, including but not limited to volume groups and logical volumes, and of course also including physical volumes. Now right now this is on a best fit basis, so double clicking allows us to manipulate it. And there's a little extra real estate towards the bottom, so let's hide the top panel. And we can also even hide the bottom panel if that'll do us any good, and obtain a little more real estate or move it to the side. So now this allows us to bring this into the window a little bit better. So to get a sense for what's happening here, on the left we see the typical LVM hierarchy. Another way to look at the LVM hierarchy is from the perspective of the volume group first, containing the abstracted items for logical volume and physical volumes. So for example, let's begin by examining the volume group that was set up during the installation. When you highlight volume group, in this case VG_hostname or Linux CBT serve1, you see in the middle of the screen a graphic which represents the storage. It shows the allocation of the storage within the volume group. It shows, for example, that LV root occupies the majority of the space. The swap partition occupies a small piece of the space. So selecting each section shows you that section and where it corresponds to physical storage. Notice that below it shows that LV root corresponds to the large segment of SDA2 occupying 8301 extents. LV swap corresponds to the small section which occupies 256 extents. It's a gig, and 256 times the appropriate size of each, which would be roughly times 4 times 10 to the first or so 40 megabytes, gives us that particular storage, and ditto for the other one, which is roughly 32 gigs. So LV root occupies 8301 extents times roughly 40 megabytes, which gives us the 32 gigs that it's using. So this is the volume group, and there's a description on the right. We can move this in a bit to just take advantage of our GUI. Again, this is a limited resolution, so we don't see much. It's a bit hard to maneuver, but we can drag this over to read on the right the properties for the volume group, which includes metadata that's important, including its name, whether or not it's clustered, the format, the extent sizes, and so on. So this shows that the layout of the disk is what we expect. Everything we saw when we ran LV display and VG display, and it shows the extents as 4 megabytes as opposed to 4 or 4 times 10 to the first 40 megabytes. So it's really 4 megabytes per extent times the number of extents gets you the total storage. So let's pick, for example, LV swap, and this piece occupies 256 extents at 4 megs each for a gigabyte. So let's move back over to the left and expand the hierarchy for VG Linux CBT Serve 1. And here's the physical view of storage. So insofar as this volume group is concerned, it's allocated across one physical disk, dev SDA, and the partition dev SDA2 is the primary partition where we can find the root file system. And here again is another breakout of the storage. Notice the options below, the ability to remove the volume from a volume group, which we certainly don't want to do on the primary disk, or migrate selected extents from a volume. So if you remove this storage from the volume group, then you can migrate it into the swap, or vice versa if you needed extra space, but that wouldn't help us. Perhaps on this system, the only partition that's worth tinkering with would be the swap partition, because it's okay if we go without swap for a period of time, but not without our root file system. So we wouldn't want to do much with that root file system. Here's a logical view of the storage, and the volume group occupies the following space, with LV root being the bulk of it, and you can drill down on each piece to see how the storage is represented. For example, with LV swap, remove logical volume, this is equivalent to LV remove. You can take a snapshot of it, which is a backup. You can edit the properties of it, which brings up metadata concerning size, and we're not able to at this point resize it because there's no additional space. The types of file systems that are supported, and if you make changes you can revert those changes. So properties of each object shows you those properties, and for example, look at root. We can reduce it. There isn't additional space within the logical volume to extend it, but we could reduce it if we'd like, freeing space for something else, altering the mount point, and so on. So this is the primary volume group. We're not interested in making changes here. We are interested in making changes in vol group opt. So vol group opt, this is the layout of vol group opt, which it's with its log vol opt. Notice the unused space, 673 extents times 4 megabytes. So this space can be allocated. Also notice the physical view. The logical vol opt consists of the following partitions from different disks: SDB4, SDC4, and SDC3. Number of extents are shown in each case. So this is a case where we've built a logical volume out of the pieces from various disks. In this case, from 2 separate disks, 3 separate partitions. A physical view shows the physical volumes. This is the equivalent of executing PV display, SDB4, SDC4, and SDC3, and that shows us the physical layout. And again, perhaps just to compare and contrast the GUI to the shell, let's just find a root shell here and execute the commands that are of interest. Let's log into that remote system and execute PV display, which will show the 3 disks. SDA2, well, SDA2 belongs to the other volume group, so SDC4, SDC3, and SDB4. So B4, C4, C3 belong to vol group opt. If you drill down to the individual hard drives, for example SDB, you see the partitions associated with SDB. And this is dev SDB4. Now with SDC, which has 2 partitions, this is the first, SDC3, and this is the next, SDC4. and it shows wherever there's free space. So for example, SDC4 contains 673 extents free. Just multiply by 4 megabytes to get the total size. So there is space to make changes. Now normally when we make changes, as we've done from the command line, we do so at the logical level. So this is where you make changes to the actual logical volume. Log vol opt. Logical view, the hierarchy header, shows you the various logical volumes. So you're not able to make an extension to the top level of the hierarchy, but if you select the individual item, then you can determine if it should be extended by editing the properties. So if you recall, we made it 15 gigabytes before by using LV resize, and that means from the shell, if we do a df-h on that remote system, well, first LV display dev vol group opt log vol opt should show that it's 15 gigs, and then df-h for the mount point opt should show that it's 15 gigs. So as a task, let's go ahead and extend the storage and see extend storage of dev vol group opt log vol opt to 16 gigabytes. And let's navigate back to our tool. This is the pop-up. So now to stretch this to 16, we can either type in 16 or drag to 16, either or. And of course, automatically the remaining space is calculated. Notice that this logical volume is not mirrored because it isn't checked. That is a feature of LVM, the ability to mirror logical volumes so that you have some form of redundancy. ext4, it mounts at opt. It mounts when rebooted and will be mounted, and of course this is a reference to etcfs tab, and will be mounted as a consequence of making changes. So let's go ahead and stretch this out to 16 gigs. This sends the appropriate commands to the command line, and it will reload the interface to show that the logical volume is now 16 gigabytes. But of course, the file system doesn't automatically detect the changes. So from the perspective of the logical volume, log vol opt, it is now at 16 gigabytes. Editing the properties should show that it's 16 slightly over. Now let's see what the perspective is from the shell. It's Alt-Tab and re-df-h opt. Notice that the GUI took care of the step for us. So that's one advantage over the shell. It cuts to the chase and sends the appropriate commands for us that are necessary to reflect the changes as soon as possible. So let's just note that that is a neat feature. Note, GUI will send appropriate commands to system to resize LVM. Perhaps we should list this using alphabets. So 1, resize logical volume, in this case log vol opt, and 2, resize ext for this particular volume for fs to appropriate size. All on the fly without us having to do what we did before, which was to first resize the logical volume, then resize to fs the ext4 file system. So it reduces the steps for us, making the process much more manageable. And again, you can view it from any perspective to see the size, move this around, and get a sense for what it's currently allocated to. So it's still 17 gigs. Now, how do we add new storage into LVM as we've done from the command line? Here we see the partitions and dev SDA, dev SDB, dev SDC. Dev SDB has unpartitioned space. This is space that could be manipulated depending, and dev SDC also has unpartitioned space. But supposing we wanted to introduce new storage as we've done from the command line, well, what we'd need to do is create a partition of type LVM. And we can do that, of course, using parted. And once the partition's available, add it to the storage. So let's see what's happening here. In fact, perhaps we'll just remove all the storage and rebuild the LVM altogether, because we probably have reached the limit of primary partitions, so we'd have to do some finagling. For example, let's fdisk L dev SDB, and it has 4 partitions defined, of which one is swap, and SDC also has 4 partitions defined. Now, since the data in opt are not important, in fact there's nothing there, we could simply remove the whole structure altogether and recreate it. So let's make that our task with the GUI. So we'll create a new task, and that is D recreate LVM hierarchy. This may entail rebooting the system, since we'll be wiping partitions. And perhaps we'll label this as number 8 and then have substeps. So first, parted and clean up the different partitions. So we can start with dev SDB. Remove partitions and create new LVM partitions. And perhaps we'll create 1 LVM partition per disk and leave some extra space, perhaps for swap or for extensions later on. So let's go to a shell. In fact, let's close out the GUI, because we're going to make these sorts of changes, and we'll quit this. And on the local system, the remote system, Linux CBT serve 1, let's parted dev SDB. So now if we print the partition table, there are the 4 partitions. Notice that there's a 10 gig partition, the ext4 file system partition that we made earlier. Let's just quit dfh to be sure that the partition isn't currently needed. And in fact, B1 and C1 are 10 gig partitions that we should unmount and remove. So let's umount dev SDB1 and C1. And we'll also modify etcfs tab to reflect the fact that we'll be no longer mounting these partitions. And in fact, the swap partition, that's dev SDC 2 and 3, those will all be removed. So we'll get rid of those as red, well, so we can start over. And this volume will also be removed. So let's do a mount, and we still have logvol opt. So let's umount opt and then redfh. So now we're back to the original status of the system. Logical volume for root, 1 for boot, because it was, of course, smaller than 50 gigabytes, so it didn't make a home partition dedicated. So now we are at a state where we can clean things up. Let's just include a preceding step, and that is A, unmount any partitions tied to dev SD, and we'll just use a character class to describe BC. So either drive, which of course includes SDB1, SDB2, SDB3, 4, and same on C. 2, we want to clean up the partitions and create new partitions now that we have unmounted everything. So let's reparted and print the table, and this is indeed the table that we want to wipe. Now, to delete these partitions, you can indicate the remove option, RM, or type help, and you'll see RM as an option, removing each partition as you see fit. And let's remove 2. SDB3 is actually swap. We didn't swap off, so we have to turn that off. Let's print, so 3 is still there. And let's remove 4. And let's quit swap on S. In fact, we did not swap off. So swap off dev SDB 3, dev SDC 2, and let's swap on S again. Now it's been cleaned. The swap file 1G can remain. So let's part it to return and print the partition table and remove partition number 3. So it's now been removed. So now it's clean and we are free to create new partitions. So to create a new partition, let's make part, and it's going to be primary partition. We'll start at the first byte and grow it to perhaps 20 gigabytes. This will create a primary partition. And of course, we'll have to reboot to reflect the changes. So 20 gigabytes, and it defaults to ext4. And we should set its type. So set type, although we could introduce a storage using the LVM tool. We could partition it there as well, but let's just set this partition to LVM and turn it on. So that's now set to LVM. Then let's do the same on dev-sdb. So select dev-sdb. We'll print the table there, and it contains one LVM partition. That was dev-sdb, so let's select dev-sdc. So here's the partition table on dev-sdc. Let's remove these partitions. And let's print the table. It's now clean. Again, we'll make part, and it will also be 20 gigabytes. So now we have two 20 gigabyte partitions that can be lumped into an LVM storage block and associated perhaps via multiple logical volumes. Let's quit. Now, of course, we'll have to reboot the system in order for the changes to take effect. So let's go ahead and reboot the system, or init6, either or. And this will kick us out of the tool momentarily. As it reboots, our SSH session will die. And let's update our notes. So C init6, so that our new partition table will take effect. And we'll also send pings every 3 seconds to determine when the system has resurfaced, and then continue management with the GUI. So again, we use SSH with the upper X option to connect to the server to redirect the X11 screen from the remote system to the local system. And then that allows us to control the remote system's properties locally via the X11 transport over SSH, tunnel over SSH, which means it's encrypted, of course. And let's see what's happening with our ping. This is yet to come back up. System config LVM is also available on the local system. So for any partitions locally, let's DFH, for example. And we've got root and home. So if we SU in and locally try to execute system config LVM, this will bring the tool up. It's also in administration. It reads the LVM layout, physical volumes, logical volumes, and volume groups. And here it shows VG_hostname. Root takes up the bulk of the space, nearly 13,000 extents. Swap a little piece, and then home the remaining space. And you can always correlate these by multiplying the extents by 4 million, or 4 times 10 to the 6, since they're 4 megabytes, roughly, of course. And dev-sda is the disk that's partitioned, dev-sda2. And here we see how it's segmented. This is the physical disk that's associated. So if you use PV display locally, that's what will show up. The logical view, however, presents home, root, and swap. And if any uninitialized entries on dev-sda, then it'll allow you to initialize it, such as partitions that you've yet to set to LVM. Initializing means set to LVM. So for our local system, dev-sda is the LVM disk, and you can confirm that by using PV display. And indeed, dev-sda, and in fact, partition SDA2, which is 74 gigs roughly, and is then further segmented into what df returns or mount returns, which is a root partition of 50 gigs and a home partition of 20 gigs. The ping should have returned some information by now. Let's take a look. Indeed, it's back. So Let's find our SSH window. Let's see where we actually made our SSH. It's definitely not that window, so perhaps it is this one or this one. So it should be this one it was connected to recently, and we'll use X to redirect X. And let's fdisk l dev sdb, and there's the LVM partition of 20 gigs, and C. And if you're wondering whether you can use a character class, for example, BC with fdisk list works as well. So those two partitions are ready to be accessed. Let's just double check. We did not set the type on SDC1, so that's a problem. Parted dev SDC and print the table set partition 1 to LVM on, and then quit. And that should not require a restart of the system. Now, let's take a look once more at both of these partitions, and they're both LVM, which means system config LVM will allow us to reallocate those two partitions as physical volumes, that is. Now, we have not associated those partitions with LVM. So we've got partition 1 and we've got unpartitioned space. Now that's SDB1, that's what we're going to work with, and then there's also additional space. So what that means is partition 1 needs to be initialized. Let's initialize it, SDB1, and it'll be lost, which is fine. There's nothing on it that's of interest to us. Again, that can always be confirmed by consulting the df dump to see if anything ties to SDB1. And let's just find a separate window. We'll SSH as root to 192.168.75.20. It's always a good idea to double check when dealing with partitions, because once you make the change, then it's rather difficult to undo it. So df shows that the storage comes from volume group Linux CBT serve 1. So if we vg display vg underscore Linux CBT serve 1, we should see its configuration, 33 gigabytes, and let's go ahead and PV display to see which disks are associated, and it's indeed just SDA2. So we have nothing to worry about with respect to SDB1. So we'll tell it that it's okay to wipe it out and make it an LVM physical volume. Now it's a physical volume. It's painted red, and it can be assigned to volume groups. Notice below, create new volume group or assign the storage to an existing volume group, such as the one created during installation. Now on SDC, partition 1, which is black, has not been initialized, meaning it's not been made into a physical volume. That's just the pv create command. So let's go ahead and initialize this. It's now red. So now we have two disks that can be added to an existing or new volume group. So let's pick the first disk, and if you're in the volume group context, for example, notice no option to add here. So go to the disk and associate it with a new volume group. Let's call this volume group vol group opt again, and it's limited to maximum physical volumes of 256. Same for logical, 4 megs on the extends. It's not clustered. You can cluster, but we're not clustering currently. Let's click on OK. That will create, using VG create, vol group opt with one disk, SDB1, which means it's 20 gigs currently in storage. So this is the space. It's not yet assigned, and it contains one disk. Now, we still have unallocated volumes, meaning volumes that are labeled type LVM. So let's add this to an existing volume group, vol group opt, which is currently approximately 20 gigabytes. And we'll add it to this, which will make it roughly 40 gigabytes momentarily. So now the logical volume consists of two disks with equally sized partitions. we've yet to actually make logical volumes to be associated with mount points, and that's the next step in the process. But looking at the hierarchy, vol group opt is the entire storage band, which represents two equally sized partitions, which represent two physical disks for optimal performance. So next, let's create a new logical volume, and we'll name it the same thing, log vol opt. These are options that can be specified when using the lv create command from the command line, whether or not it's striped, mirrored, or just linear, which means a volume set. So this is where we specify the size, either in the input field or with the slider, and we do so using one of the size indicators. So let's make this 30 gigabytes, and that'll give us a little room to grow in the event that we need to. So we'll just make it 30 gigabytes. And what file system should be associated? ext4. So this will send the appropriate commands, add to etcfs tab, mount it, and we want to mount it in /opt, which currently is unmounted. So let's click OK, and this will send the requisite commands to the system, which we would normally type in otherwise, which includes building the file system, etc. So we'll wait for this to run, and let's just check our notes. This is going to reload momentarily. Let's see where we are in the process. So we rebooted, and then once those partitions are in place, we had to set the types, the LVM for SDC1, or set the type, that is, for the single partition. And once back up, use system config LVM to create volume group from dev SDB1 and dev SDC1. And then, of course, mount it somewhere. So E, create logical volume, log vol opt, and last but not least, mount at /opt or some desirable location. Let's return to our tool. So this is where we stand, log vol opt, with some unused space, which means we can extend it when necessary. Now let's take a look from the shell on the server at the current configuration. There we see the partition mounted at /opt. So it's now available. And let's PV display, which shows SDC1 and SDB1, which are members of vol group opt. The other is the installation-based volume. And of course, VG display will display the two volume groups, installation volume group and the one we just created with system config LVM. And last but not least, LV display shows the logical volumes, swap, root, and opt, the one we just created as 30 gigabytes, which can be extended using system config LVM. So this is how you use the tool. Now, it isn't always best to rely upon the tool, but rather best to rely upon using the shell tools, PV, VG, and LV respectively, to create the three tiers of your LVM hierarchy. So in the event that the tools are unavailable or non-functional for some reason, you can still create an LVM hierarchy.